Hello and welcome. Today, we're diving into the incredible story of how we taught computers to understand us. It's a story you probably haven't heard, all about a massive problem and one woman's truly brilliant idea that changed everything. Seriously, think about it. Every single time you click a button, type a message, or swipe on your screen, you're giving an order. But how does that simple command, something you and I understand, get translated into something a machine can actually do? It kind of feels like magic, doesn't it? Well, it's not magic, but it is the result of a revolutionary concept. All right, let's break this down. On the left, you've got a simple human thought, play video. Easy enough. But on the right, that's what a computer actually gets, a long, messy stream of zeros and ones called binary code. Just look at that huge gap between our world and theirs. That was the challenge early pioneers were up against.
In that gap, that challenge, represents our first major hurdle in this story, what we're going to call the binary barrier.
You know, for the very first programmers, this wasn't just some abstract idea. It was their daily grind. Every single instruction, for every letter, every number, had to be painstakingly translated by hand into these long strings of ones and zeros. I mean, can you imagine how slow and tedious that was? It was incredibly frustrating, and if you made one tiny mistake, just one, the whole program would completely fail. But all that frustration, it actually set the stage for a true visionary to come along. So let's meet the hero of our story, the one and only Grace Hopper. Grace Hopper was, let's just say, a force of nature right from the start. Get this, at just 7 years old, she took apart every single alarm clock in her house just to see how they ticked. That same curiosity drove her to get a PhD in mathematics, and her courage led her to join the Navy during World War II. Then, in 1944, her life took a fateful turn when she was assigned to one of the world's very first large-scale computers. And this is so important. When she first saw this massive, room-sized computer, the Mark I, she wasn't intimidated at all. Nope. To her, it was just like one of those alarm clocks from her childhood, just a lot bigger. It was another complex machine, and she had this overwhelming need to figure it out, to understand it from the inside out. And it was that unique way of looking at the world that led to a breakthrough that would change computing forever. Which brings us right here, to the idea of a computer that could actually understand us. So while everybody else was seeing this complex mess of wires and switches, Grace Hopper saw a pattern. She had this incredible aha moment. She realized that a computer's memory stored information in very specific, orderly locations. You know, kind of like books on a shelf in a library. And that library idea, that was the key to her greatest invention, the compiler. So what is it? Well, the compiler is a special program that basically acts as the master librarian for the computer. Its whole job is to take our simple, human-readable commands and translate them into that messy binary code the computer actually needs to work. And here's exactly how her library analogy works. It's so simple and elegant. Okay, step 1. A programmer writes a command in plain English, like add these two numbers. Step 2, the compiler, our librarian, looks up that command. Step 3, it finds the right call numbers, which are the specific binary instructions the computer needs. And finally, step 4, the computer executes that binary code and performs the action. It was brilliant. It changed everything. Now, you'd think an idea that brilliant would be accepted immediately, right? Well, not exactly. Which brings us to the next, kind of frustrating part of her journey. From rejection to revolution. Her idea was it was seen as completely out there. I mean, the experts at the time were absolutely convinced that computers were for numbers, period, not words. They truly believed that a machine could never, ever understand English. And because of that stubborn belief, for 3 whole years, her revolutionary invention just sat on a shelf. It was completely untouched, totally ignored by her peers. But then, in 1952, the tide started to turn. One of her superiors finally gave her the shot she had been waiting for, a real chance to prove that her compiler wasn't just some crazy theory, but a real working invention. And she did not waste that opportunity. She presented the A0, the world's very first compiler. And that quickly led to an even better version called the B0. And that laid the groundwork for something even bigger, COBOL, the first truly user-friendly programming language developed by a team that she led. COBOL was an absolute game changer. It stands for Common Business-Oriented Language, and it was designed to be fast and intuitive. It could handle real-world stuff, like creating bills or doing super complex calculations in a flash. This was the language that finally took computing out of the science lab and put it into the modern office.
And that brings us to our final section, where we get to look at the incredible, lasting legacy that Grace Hopper left behind.
Just think about this for a second because it's pretty mind-blowing. More than 60 years after it was invented, an estimated 80% of today's business transactions are still powered by COBOL. Her work isn't just a piece of history, it's the invisible engine running our modern economy right now.
But her legacy isn't all just about serious code. It's actually woven into the culture of technology itself, including a pretty funny story and a very, very famous term. So, the story goes that one day, her team's computer just stopped working. Of course, being Grace Hopper, she opens up the machine to figure out what's wrong. And the cause of this huge technical problem? An actual, real-life moth was trapped inside one of the relays, shorting out the circuit. She carefully pulled the little guy out, taped it into the team's logbook, and with this perfect, dry sense of humor, she wrote, "First actual bug found."
And that, right there, is how she helped popularize the terms we all use today. A bug is any error in a computer program, and debugging is that painstaking process of hunting it down and fixing it. And it all started with a real insect. Grace Hopper looked at an impossibly complex machine and saw a simple library. She saw a connection that absolutely no one else did, and it unlocked the future of computing for all of us. Which kind of leaves us with a pretty big question, right? What future are we failing to see right now just because we've convinced ourselves it's impossible?